Hello, this is TJ and welcome back to my channel. Today I'm going to show you some tip on the back chamfering tool, and this is what you see on the screen. This is a back chamfering tool. It is a special tool with different section. The lower section here and the upper section here. With the lower section we can use this as a normal chamfer tool, and we can do chamfering on the top of the part like this. And with the upper section we can do the back chamfer operation. So this tool is going to be very useful in some cases, but the thing is, now I'm using the Mastercam 2022 and we haven't got any specific toolpath for this kind of tool. So I think in the future Mastercam they will release some new toolpath, or they will integrate this kind of tool in the chamfer toolpath, but not now. So far we need to do some manual work to use this one. Okay, so before we create a tool, I'm gonna show you two different methods I'm gonna use in this video. The first one is I call that using the tool node and use combination with the contour toolpath. You can see here I have two sample toolpath. You can see I use the contour toolpath with the back chamfer tool, and if you can see I have some note here right after the name of the tool. You can go to here and see this it's just a normal contour 2D toolpath, and right here I have some stock to leave and stock to leave on floor and wall. So what's this number come from? You just take it from here, from the tool node right here. Yep. And you can also see it here. You can see I put some note on the tool, and right when you call that tool you can just input this note into the field here for stock to leave on wall and floor, depend on which kind of chamfer you are doing, back chamfer or front chamfer. So you can see here I split it into 4 number, 2 for back chamfer and 2 for front chamfer. You can see BZ and BXE for back chamfer. That's tell what is the number to input into this field. So in the first toolpath I do a front chamfer on the top, so I know that what number can be used. That is the front Z, FZ, and the front X, FX here. I just input those number into this field. Minus 1.25 millimeter for both X and Z, and then I move the tool to the correct position for the toolpath. It's quite simple, right? So where's the number come from? Quite easy. If you used to work with this tool, you're gonna know how to text those number. Okay, we go back to the part here and see. The first thing is you need to select the contact point for your tool. Just any contact point you want. For example, I want the contact point must be at the middle of this lower cutting edge, or you can move it and move the contact point a little higher, so you get a higher cutting speed just around here. So the first thing we need to locate the contact point we want. So after we got a contact point, you can do some measurement from the tool tip to the contact point like this. For example, for front chamfer I'm gonna measure okay, first I measure the distance between the tool tip and the edge we want to do the chamfer in the Z axis. So this is gonna be 1.25, and we do another measurement for the X and Y distance. So this number gonna be input in the stock to leave on wall, and and this number gonna be input in the stock to leave on floor, so it should be minus 125 and 125. So you can see where this number come from, 125 and 125 for front chamfer. FZ and FXF stand for front. Okay, so the same with the back chamfer. We also need to find the contact point for the tool. It's depend on you. You can select any contact point you want. So again, I want to put it right in the middle of this upper section, so I do the measurement again to find the number. Okay, so this one should be 125, like this, just the same with the front chamfer, and we measure the Z direction. So it's gonna be 3.75 measured from the tooltip to the edge we want to do the chamfer here. Okay, so again we got this number, so I write down those numbers to here, and when you need to use this, just go to the cutting parameter and go to this window, and you can see the notes for the back chamfer. Yeah, the Z should be, the stock to leave on floor should be minus 3.75, and the stock to leave on wall should be minus 1.25. Yeah, very easy. So you just measure it one time and write it down to use later. This number just make the tool just contact with the part. So if you want to make chamfer, you need to adjust this number a little bit, depend on how big you want the chamfer should be. So if you want to do a 0.2 chamfer, it should be 1.45 instead of 125. Yeah, that I just show you the first method using the tool node for moving the contact point to the correct position, and now I'm gonna show you how we can create a tool if you want to use this method. Okay, first we need to have a level that contain the tool profile like this. I create this. You just need a half profile of the tool without this line along the y-axis. You don't you can you need to remove this line if you want it to work, so you just keep the half profile of the tool with the correct dimension, and then you put it in a specific level. In this case I put it on the level number 1. Okay, and after that you can go to toolpath here in tool manager, do a right click and select create tool. So you can select some kind of tool here for a custom profile tool, but for this method, just using contour toolpath, no chamfer toolpath, I recommend you use this kind of tool, the flat end mill. Very simple and it can be done. Okay, after you select the flat end mill, you can see this tool is need to be import a profile for this. So you click on this button, import profile, and then select the level that contain the tool profile you want. In this case that is number 1, and okay. So this is our tool, very simple, from custom profile. It is actually an end mill with a special profile. Okay, so you can see this is the Mastercam tool, and this is the tool with the profile. Okay, so you just the thing you need to input is just input the correct tool diameter, and that's enough, and also tool length, and that's enough. You can try. You can also do adjust the cutting length to fit your tool like this. And yeah, input some cutting parameter for this, and after that, just after you measure and you got the note here for the contact point, you just input it right after the tool name here. Okay, So very simple for creating the tool with this method. Just make a custom email with the profile we got. Okay, so I just show you the first method that we write down the contact point of a tool, and we can use it every time we want, and also depend on the part. We can adjust the contact point by just changing this value and or this value. So very simple and easy to use, right? So that's the first method. It's using a flat mail with custom profile like this. And the second method is a little crazy, but if you like it, I'm gonna show you. Okay, so I call this method is using a hidden chamfer. Yeah, it's different with the first method that we use a flat mill with custom profile. In the second method, we use a chamfer mill with custom profile. You can see this. Let me show you. You can see the name of the tool. This is the flat mill, and this one chamfer. That tell you the type of the tool you created. Okay, you can see here. Yeah, instead of a flat mill, I use a chamfer mill when I create a tool, and you got something like this. This is a chamfer tool inside a back chamfer tool. So because it's a chamfer tool, we can use it with a chamfer toolpath. Yeah. So let me show you how this works. When you're using this method, you can change the contact point of the tool by modifying the outer diameter of the chamfer here. For example, this one is 8 millimeters. You can see with the 8 millimeter chamfer, we got this contact point should be here. Yeah. And if you want to move the contact point of the back chamfer to around here near the tip of the tool, you can make this bigger. So for example, you want to be 9, and you need to change something here in order to make it work. Okay, so we redefine the chamfer, and we can make this a little bit short. Yeah, like this. Yes, so you can change the diameter of the chamfer, so you can know where's the contact point. So this is a chamfer, so we can use a chamfer toolpath with it. The thing is, you need to make this point of the chamfer contact with the part. Okay, I'm gonna show you how we do it. First, I'm gonna use a normal chamfer tool so you can see what happened. For example, I want it to do the chamfer here on the bottom edge of the part. I go to the toolpath diameter, and instead of using the bottom offset, I select the top offset. So if top offset equal to 0, this point of the chamfer we will move to the top of the edge. So that's what we want. Tool view, turn on the section. So this is what happened when you select top offset here by 0. You see what happened? So the tool contact with the edge at the big diameter. So we do the same here with our special tool. So when we select top offset and the value is 0, the tool will contact here right at the contact point we wanted. So that's why we put a chamfer tool inside the back chamfer. So I hope it's not too crazy to understand. Okay, so I got the special tool here, the back chamfer, and now because is a chamfer, so I can use the chamfer toolpath, and instead of select bottom offset, I just select top offset, and I don't care about anything else. So with top offset by 0, you can see what happened here. Okay, I backplot the toolpath. Bang! You can see that we got the tool contact at the part at the design contact point. So if you want the tool contact with the part at a lower position, you can change the tool diameter here, like I show you, maybe 9mm. This one is 3 and this one is 2. Yeah, like this. I move the contact point by making it a little bit bigger for this one. You can see the back chamfer tool diameter is not changed. We just change the hidden tool inside it. Okay, I think this the method just for demonstration only. I don't know if you want to use it or not. Just quite crazy. Okay, so after we change the tool diameter, you can see the tool contact at a lower point. So if you want to make a chamfer, you need to input this value. For example, you want to cut a 0.5 chamfer like this. You just need to input minus 0.5, so you got a 0.5 chamfer like this. Yeah, very simple, right? You can see. Yeah, I can make the cutting length a little bit longer, so you can see. Maybe 5mm. Okay, this would be like this. This is the chamfer, the hidden chamfer, and this is the back chamfer. Yeah, you can change the cutting length, no problem. Just show it reality. It show reality. Okay, okay. I will turn on the model with the chamfer already created, and you can see it easy. Okay, yeah, you see that. Yeah, so this is the back chamfer. For the back chamfer, you just need to select chamfer toolpath, select top offset in this option, and then you input the value you want to make the chamfer. Very simple, right? Yeah, that's the back chamfer. And how about the front chamfer? Like this. So I want to go back to the model without chamfer here, and how about when we do the front chamfer like this? Okay, we go to the parameter. So this is the parameter we set for the back chamfer, and for the front chamfer there's a little different. If we keep like this and run, you can see it's not correct. It's not contact at the correct point. It need to be contact at the lower section here. So to do that, for the front chamfer, you need to add something here, add the stock to lead on floor. And how much is this value? Very simple. If you can do some simple calculation, you're gonna know how much to put it here, and I give you the formula right now on the screen. So the stock to leave on floor is gonna be equal to, I'm gonna show you. Okay, and you know the correct diameter of the back chamfer. So you take that value and minus by this value, and minus this value, the diameter of the chamfer tool we defined. So that would be the value we input here. So in this case, the back chamfer is 10mm, and the hidden chamfer we define is 9mm. So this value should be 1 millimeter. So let's see what happened. Yeah, and now you move the tool to the correct position to do the front chamfer. See that? Everything just keep the same with the back chamfer. Is just at this value. Now we can see how they work on the simulation. I think it's very simple, right? So this is the front chamfer, and this is the back. Yeah, just remember to put enough of lead in and lead out to avoid the tool hit into the part when it doing the plunge and retract movement. Okay, so that's all for tonight, and thanks for watching again. I hope you can come back in my other video. Okay. Oh, crazy. See you again. Bye bye.